Welcome to This Explainer. Today we're going to unpack an absolutely excruciating medical mystery. We're talking about kidney stones, why your body forms them, the frankly fascinating microscopic science behind them, and most importantly, exactly how you can stop them from ever taking root. Now, if you ask anyone who's actually passed a kidney stone to describe the experience, trust me, they are not going to use polite, sterile medical jargon. No, they'll describe this unforgettable, gripping agony of passing what is essentially internal gravel. It's widely considered some of the most intense physical pain a human can possibly endure. It usually starts as this sudden, sharp ache in your flank or lower back that just fiercely radiates downwards. But as you'll see, even though the pain feels like a sudden ambush, the stone itself definitely didn't just pop up overnight. So that brings us to the big question, right? If this pain strikes completely out of nowhere, but science tells us these stones actually take weeks, months, or even years to build up, why exactly does your body create these hard, jagged mineral deposits in the first place? Like, what is going wrong in your biology to literally manufacture gravel? To figure that out, here's our roadmap for today. First, the unseen battle. Second, the science of supersaturation. Third, the 4 types of stones. Fourth, your daily triggers. And finally, how to prevent them. Let's dive in. Section 1, the unseen battle. Because while the pain feels sudden, a kidney stone is really the end result of very quiet, microscopic biochemical shifts that have been happening deep inside your kidneys over a really long period of time. Which brings us to Section 2, supersaturation. To really understand how this gravel builds up, we have to appreciate the sheer, unbelievable volume of work your kidneys are doing for you every single day. Get this, every single day, your kidneys filter a massive 180 liters of fluid. 180 liters. Their entire job is to pull out metabolic waste and excess minerals, things like calcium, oxalate, and uric acid, and then condense all of that down into just 1 to 2 liters of urine. Think about that ratio for a second. You're taking a vast amount of material and shrinking it into this highly concentrated fluid cocktail. Usually, these minerals stay perfectly dissolved, but sometimes that delicate balance tips. And that brilliantly illustrates our core mechanism here, supersaturation. Imagine a tall glass of iced tea. You stir in a spoonful of sugar, and it dissolves perfectly, right? But if you keep dumping spoon after spoon into that same glass, eventually the tea just can't hold any more sugar. The liquid becomes supersaturated and solid sugar crystals start settling at the bottom. The exact same thing happens inside your kidney. When the concentration of waste minerals gets too high relative to your water volume, your urine gets supersaturated, and those minerals simply cannot stay dissolved anymore. When that concentration hits the breaking point, this process called nucleation kicks in. Basically, tiny microscopic crystals drop out of the fluid, and they immediately look for a place to grab onto. They usually anchor onto these microscopic tissue patches in your kidney called Randle's plaques. And from there, it's a slow, agonizing construction project. Mineral by mineral, day after day, they slowly grow. It's kind of like a stalactite forming in a cave until, boom, a full-fledged kidney stone is born. Moving on to Section 3, the 4 types of stones. Because as it turns out, not all internal gravel is built the same, and knowing your specific type is the absolute key to stopping it. As we can see here, calcium stones absolutely dominate the pack, making up about 80% of all cases. These are usually calcium oxalate stones, which form when calcium links up with oxalates, stuff you find in healthy plant foods like spinach or nuts, while inside concentrated urine. Next up are struvite stones at 10 to 15%, and these are totally different. They're actually driven by specific bacteria from upper urinary tract infections. Then you've got uric acid stones at 5 to 10%, forming when your urine is highly acidic, typically from breaking down a heavy meat diet. And finally, making up less than 1% are extremely rare genetic cystine stones. Now, each of these types has its own unique personality, and some have incredibly sneaky hidden dangers. Uric acid stones, for instance, are so smooth and dense that they can literally hide right on a standard X-ray, making them super frustrating for doctors to diagnose. On the flip side, struvite stones, since they're fueled by bacteria messing with your urine's pH, can grow shockingly fast. They can balloon into these massive branch-like shapes called staghorn calculi that can actually grow to fill the entire inside of your kidney. No thank you. All right, Section 4, triggers of formation. What everyday habits are actually throwing off your biological balance and triggering this dangerous crystallization? Well, it almost always comes down to 3 main imbalances: too little fluid, too much stone-forming material, or not enough natural defenders. The single biggest driver, hands down, is chronic dehydration. If you aren't drinking enough, you're creating low-volume, super dense urine, which is the ultimate playground for crystals to meet up. High-salt diets are another massive culprit. Eating too much sodium literally forces your kidneys to dump excess calcium straight into your urine. Heavy meat consumption is another one. It drops your urine's pH right into the acidic danger zone. And finally, lacking natural crystal defenders, specifically a compound called citrate, leaves your kidneys completely wide open to attack. Which brings us to a mind-blowing misconception I like to call the calcium paradox. Because 80% of stones are made of calcium, people naturally think, hey, I should probably just stop eating dietary calcium, right? Actually, scratch that. Doing that makes it worse. It's a huge myth. If you cut out dietary calcium, the free oxalates in your food have absolutely nothing to bind to in your digestive tract. So instead of passing harmlessly through your gut, they get absorbed straight into your bloodstream, get dumped into your kidneys, and absolutely skyrocket your stone risk. The biological reality is that you actually must eat calcium and oxalate-rich foods together in the same meal so they safely lock together in your stomach, not inside your kidneys. Finally, Section 5, Prevention. The really good news here is that up to 80% of kidney stones are completely preventable once you understand these risks and make a few strategic tweaks to your day. So how do we actively shut down this supersaturation process? First, hydrate aggressively. But the goal isn't just about what goes in. You want to drink enough to actually output 2 to 2.5 liters of clear urine every single day. Second, use that calcium paradox to your advantage. If you're having a high oxalate food like a spinach salad, make sure you pair it with a side of dairy. Third, squeeze some fresh lemon or lime into your water. This floods your system with natural citrate, which physically blocks crystals from growing. Fourth, keep your sodium strictly under 2,000 milligrams a day to stop that calcium dumping. And fifth, if you ever do pass a stone, grab it, save it, and take it to your doctor for lab analysis so you know exactly what kind of gravel you're up against. So, knowing what we know now about exactly how these agonizing, jagged little crystals form in the dark of your kidneys, I want you to ask yourself a serious question today. Are your daily hydration and dietary choices quietly building internal gravel right now, or are you actively flushing it away? Think about that the very next time you pour yourself a glass of water. Thanks so much for joining us for this explainer, and we'll catch you next time.